In this video, I'm going to go over another example of linear interpolation. Remember, that's a method we use to estimate a median when we've got grouped data. So this is the same question that we looked at before, where we estimated the mean. So we've got this chap, Joshua, who's investigating daily rainfall in Herne, and he's got all this data about daily rainfall in millimeters, and he's got it grouped. So we've got the 121 days that have 0 to 0.5 millimeters, we've got the 10 days that have 0.5 to 1, etc. We've got the midpoints there, we're not going to use them in this question. So linear interpolation to find the median. So the median day, if we had them all listed together, is the middle day. So the first thing to do is to figure out what's the middle value. Well, it doesn't tell me how many days I've got, so I need to add up the frequencies. So 121 plus 10 plus 24 plus 12 plus 17 is 184. So I'm looking for the... No, I'm not looking for 184th because that's all of them. I'm going to divide that by 2. Remember, we don't do a plus 1 when we've got group data. Okay, no need. We just divide it by 2. So we're looking for the 92nd day in this list. So where is it going to be? Well, look, the first 121 days are all in the first group. So that means that the 92nd day is in the first group. So I like to put a little star in the group that I know the median lies in. So the median is in that group. I just need to work out what fraction of the way into the group it is. Remember, my method here, my approach is going to be, I'm going to first find the fraction into the group. I'm then going to multiply by class width. And finally, I'm going to add on the lower bound. So that's the way I like to think about finding the median using linear interpolation. So what fraction of the way into the group it is? Well, there are 121 in the group, and I want to find the 92nd in the group. Well, that's 92 out of 121. So that was actually easier than it was in the last question because it was the first group. I didn't even need to do a cumulative frequency. And I'm going to multiply by the class width, and the class width is 0.5, so I go from 0 up to 0.5. And then I'm going to add on the lower bound. The lower bound in this case is 0, because that's the smallest number down here. So 92 out of 120, and multiply that by 0.5, and I get 0.380. So that is 0.380 millimeters, and I do like to include that because in general in stats I like to give my answers to at least 3 significant figures unless they tell me otherwise. Remember, in mechanics it's not always that often you want to round to 2 or 3, particularly if you've used G. Check out my mechanics course if you don't know what I'm talking about. But in stats it's good to give at least 3 significant figures, even if that last one is a 0. Alright, so I hope that was useful to see another example of linear interpolation. I'll see you in the next video.